Hello everyone. So in this video we are going to talk about UVM driver, and it is one of the most important component, and it is going to be the first component that we will be discussing here. So let's begin. So I will name it just driver, and it should be extending the class inside the UVM library known as driver, UVM underscore driver. And like sequence, it also have a parameter, and that parameter is similar. It should have the transaction class. So I will write that transaction class right here. So you have to pass the transaction class as a parameter to both the sequence and the driver. So the very first thing we will do is to perform the factory registration. And since this is an object, the UVM driver is an component, not an object. So instead of using UVM object utils, which we did with our two previous classes, we will be doing UVM component utils. And inside that, just like the previous factory registration, we will write the name of the class. Now we will move on to creating two different handles. So the first handle will be of that of transaction, and here instead of T we could just write TR. And the second thing which is very important, which we would like to mention right here, is the interface. So if you will take a look at the test bench environment architecture of UVM based test bench, you will see that driver and the monitor are the only two things that are interacting with the DUT, and they are interacting via the interface. So here we have to mention the interface. So moving on to our design, the name of our interface was add_if, which stands for interface. So we would just write here, and we could just write, let's name it AIF or anything you want. Let's just write it VIF. So there is one more thing that you have to add, is that inside this class you have to declare the interface to be virtual. So I will add one more keyword. So the interface should be declared as a virtual interface in both the driver class and the monitor class. So after we are done declaring the instantiation of the interface and the handle of the transaction, we will move with the very obvious thing, that is the constructor. Now, as you can take a look uh, at the constructor of our previous classes, which were objects, there were only one formal argument. But in case of component, there will be two formal arguments. The one will be the name, and the other one will be mentioning the hierarchy. So the components, unlike the objects, are static and they remain same during the entire simulation. So that's why it is important to mention the hierarchy, which can be done. So first we will just write the name, string name, and let's name it same as the class name. Then we will just go ahead and mention the data type UVM component, which is mentioned inside the library of UVM. And then we will write parent, and right now we will just give it a null value because the hierarchy will later be declared or later be made when you will move towards the top level classes where you will do the connection between the lower level classes like agent, environment, and the test. So inside this, just like our previous classes, we have to call the constructor of the parent class because the constructor of the parent class have formal argument inside it, and then it is a requirement that you have to call the constructor of the parent class explicitly. And this time you have to pass two arguments. The first one will be name and the second one will be parent. So we are done with the constructor of the driver class. Now let me introduce to you a new concept which is face. And I will create a separate video for face in details. Here we will just do a quick walkthrough. So there are various faces and they are categorized into three portions, into three groups and categories. So these faces are used to maintain synchronization between the UVM components so that there won't be any mismatch or missynchronization. So the first type of faces are known as the build phase. The second type of phases are the connect phase, and the third phases are the shutdown phases. So here we will be using two of those phases, and out of three of those categories, the run phases are the only categories which can consume time. And as you already know that tasks are the only thing that can consume time. So we will use tasks to declare the runtime phases. And other than the runtime phase, the other two phases can be declared and will be declared using the function since they do not contain any time or delay literals. So let's begin. So first, I will write the build phase, and build phase is very important to mention the constructor or to create the uh, object for the things that are mentioned right here. So in our case, we have mentioned the handle of the transaction. In our previous class, we mentioned that inside the virtual task body, but unlike the previous class, the driver is a component, so it has the ability of faces. So inside the build phase, we would just write the constructor of the transaction. And the second thing we will do is to write the UVM configuration DB. So I know this might be confusing, but in the later videos, we will be discussing each of things which are mentioned here in this videos in details. So for now, let's just focus on completing our UVM test bench for this very simple design. So just to mention the face, the build face, you have to write first. You have to declare that class as virtual, and then since the build phases does not contain any time, so they are functions and they will not have any return type. So I am writing void, then build phase, And the argument of each face should be something like that. UVM face face. So all of the face will have the same argument. So let's just end the function. So like our constructor, we also need to call the constructor of the parent class explicitly in terms of face also. So I will do that. And this time, instead of writing super.new, we will write super.buildFace. And then we would just do the same thing. We would just pass this argument. So this should be face. So right after calling the constructor of the parent class, the very first thing I will do is to create an object of the transaction using the create method. So to do that, you just have to write tr equals to and the name of the class, which is sequence item. Then using the scope resolution operator, I will access type ID. And then again using the scope resolution operator, I will call the create method. And inside it, I will just pass the name of the handle as an argument, as a string argument. So the third thing that you have to do is to write the UVM configuration DB. So UVM configuration DB is a sort of configuration database or a repository that is used for storing parameters in a triplet format. And in our case, we will use it to store the interface. So when we will declare the top level class, we will store the interface add underscore if to the UVM configuration database using the get method, using the set method. And using the get method inside the classes like driver and monitor, we could access that interface. So this is kind of a way of accessing the interface the test from the test class that I will show you later uh, in the later videos. So let's just begin. And so to do that, you just have to write UVM config, which stands for configuration, and DB, which stands for database. So it need an parameter, it need a parameter, and that parameter should be the interface itself. So in general terms, that parameter is the type of the data that you want to retrieve or that you want to store in the configuration database. So that parameter is interface. And remember, sorry, it should be add underscore if. And remember, since we have declared the interface as virtual, we should do the same right here. So this is the parameter. And then using the scope resolution operator, we will use the get method. So there are two methods. One is set, which will be used later in the UVM test class, and which is basically used to store the interface inside the UVM configuration database. And the second method, which is get, and this method will be used in two classes. The one which is being used right here in the driver, and the second one will be used inside the monitor. And remember, both of these classes are used to communicate with the DUT via interface. So it is basically used to retrieve the interface that is stored by the test class. So uh, the get method will have four arguments, and the first two arguments are the scope. So the first scope indicates that this get method belongs to which class. So here I just want to make it clear that it belongs to this class, and using the this method, it will just refer to the driver class. So this get method is in driver class. Then the second argument or the second scope is the relative path. The relative path specifies that this particular thing is accessible by which other classes in the hierarchy. So I will just leave it null, and because we just want this UVM config dv get method to be available to this particular class. So you could do anything. You could just do the wildcard. So using this, yeah, this could be accessible. This can be seen by anywhere down the hierarchy, starting from the UVM root. But for now, we won't be using anything. And remember, the second argument is getting passed as in string. Now the third argument will also get passed as a string, and the third argument is like is the name of the handle. So this also works as a sort of key between the get and set method. So we will discuss more about that later. So I will just declare the handle as the third argument, and the final argument should be the object or whatever thing you are storing, and we are storing the interface, which is instantiated as VIF inside this class. So I will write VIF. Now on top of that, just to check whether this get method is successful in retrieving the interface, we would just cover this up and we will write a condition, and I will write not here. So if this code fails to retrieve the particular interface inside the configuration database, we will get an UVM error. So UVM error is also very similar to UVM info, but it just works as a dollar error that you can find inside the system Verilog system task. So unlike UVM info, UVM error will have only two arguments. So the first argument will be the ID, and similar to the UVM info, which was used inside the sequence, I will just write the get type name, and this will return the name of the class itself as a string, which is driver. And the second argument is the message. There is no third argument. And as you can remember, the third argument is the verbosity. And verbosity basically sets the filter. So by default, other than UVM info, all the other display methods have uh, the UVM none, verbosity by default. So which basically indicates that they will get printed on the console regardless of whatever the priority or the verbosity is set. So the second argument is message. So I will just write failed to access interface. That's it. So this concludes our build phase. In build phase, I have mentioned two things. The first thing, if you also consider this, then there are three things. And this is just calling the constructor of the parent class. And the second thing is the creating an object for the transaction. And the third thing is the UVM config DB, in which I'm retrieving the interface. And just remember these four arguments. So right after, when we are done with our build phase, we will move on to the next phase, and that phase will maintain the communication between the sequence, the sequencer, and the driver. So here you can see that uh, this this phase, which I am about to mention, will be communicating to this methods through the UVM sequencer. So let's do it. And this particular phase should have a delay. So that's why we'll be using the run phase. And since the phase has delay, it should be task, because the function cannot contain any time literals or delays. So this is run phase, and it will have the same argument, UVM phase. So since this is not a function, there is not the requirement to call the constructor. So let's just begin. So very first thing we have to do is to write a forever loop. And it is because the driver should be ready to receive the data from the sequencer, which is being sent through the sequence. It should be ready. So it will forever checks whether any transaction is getting passed. And as per our repeat loop here in the sequence, there will be 10 iterations of transactions. So it should forever be checking. So right after that, just like the sequence has start item T and finish item T, this should also have some sort of communication mechanism. And this inbuilt mechanism is a port, and specifically it's I will just mention the concept of transaction leveling ports later in the video, but this is a port, and it will communicate with the export. It will communicate with the export of the sequencer. And you don't have to mention the sequencer, everything will be done automatically. But here in the driver, you have to mention everything. So it will just, you just have to access that port using the sequence item port. And inside this, you will write get item, get next item. And just like sequence, it will also have the handle of the transaction as an argument. So this is a special port which is used to communicate with the sequencer, and this shows that the driver is ready to receive a new data. So this will communicate using the sequencer. This will communicate with the start item T. So here, uh, just like here, if we have finish item T, here we will have uh, sequence item port dot item done, which indicates that the transaction has been driven to the DUT, so that the next transaction can be initiated by the start item. So there is a sort of handshaking communication between three of the components. And unlike this time, uh, we do not need to have anything inside its argument, because it just indicates that the transaction has been done, and it does not carry any transaction. So you just have to write item done with an empty bracket. So between this, we have to drive the data to the DUT. So this could be done just by referencing to the signals which are mentioned inside the interface. So the name of our interface is VIF. Here you can see it. And we need to drive the data to the input signals. And if you will look at here in the interface, there are two input signals. Those are A and B. So first I will pass the A, which is mentioned inside the interface, with the value of the transaction that we received from the sequence, which is getting randomized right here. And that sequence is here. So I will just refer to the transaction, and the name and the handle of the transaction is tr. So I will write tr dot a. And then we have to do the same thing for B. So uh, we are basically driving the transaction to the DUT via interface. So of course we won't drive the signal to the output. It does not make any sense because we will be expecting a response in the form of output. So we just driven both the input signals, and remember to use the non-blocking assignment, just to mention that, just to maintain the sequential logic. Here it is not important, but later in some of the videos where we will be writing a test bench for the sequential design, it will be important so that the data can be sampled and assigned after every passage of the clock or negation of the clock. So here we are done with the driver, and we will just mention some few more things. So the first thing I would like to mention is a delay. So this ensures that after every each of the transactions, there would be a delay, and this delay is important for the monitor to complete receiving the response from the duty and passing it to the scoreboard to check the test whether the test has been passed or not. So the very same delay will be used at the beginning of the monitor, of the beginning of the monitor's run phase, and also inside the test phase where you will just initiate the entire thing. So here we can add some few fancy things. So the very first thing I will write UVM info, just like I did in the UVM, just like I did in the sequence class. So the first thing will be the ID, which I will retrieve by using the get type name method. And the second thing will be the message, and I will just say the following transaction is being driven to the DUT. And unlike UVM error, it should also have a verbosity. So for now, we will just mention the verbosity as UVM none, which has the highest priority. After this, we would just access, oh wait, it should be tr. So after this, we will just access the print method, just like we did in the sequence class. So this concludes our driver class. So remember, in driver class, just like the sequence class, you have to mention the transaction as an argument. And unlike the sequence and sequence item class, driver class is component. So during the factory registration, remember to use UVM component utils instead of UVM object utils, which you can see it right here and right here. After that, you will mention a handle for the transaction class, and also you will just mention the instant. You will just instantiate the interface to be virtual. Then after you are done with your constructor, you will just write the build phase, and build phase are used inside the UVM components. So the very first thing in the build phase I did is to create an object using the create method for the transaction class, and then I using the UVM configuration DB, I retrieve the interface, and after that we will move on to the main thing, which is the run phase, where we will be driving the data to the DUT using the UVM sequence item port. And this sequence item port will be communicating implicitly with the UVM sequence item export that is present inside the sequencer class. So that's all for driver. Thank you so much.